Welcome back, everyone. We're going to be solving LeetCode 129, sum of root to leaf numbers. So we're given the root of a binary tree containing the digits from 0 to 9. Each root to the leaf path in the tree will represent a number. For example, root to leaf path 1, 2, and 3 represents the number 123. And we need to return the total sum of all of the root to leaf numbers. So we can take a look at example 1. They give us a tree of 1, 2, and 3, and they want us to return 25 because the path from the root to the leaf 2 is going to be the number 12, and the root to the leaf 3 is going to be the number 13, and the summation of 12 and 13 will equal 25. So this is going to be pretty similar to a problem we've solved on the channel before, where we had to find all of the root to leaf paths in a tree. We're going to be doing essentially the same thing, except we'll obviously be returning a summation of the root to leaf. So we're going to do depth first search to solve this. So we will have a stack, and on this stack we will contain the node, which will start with the root. We will have a visited boolean, which will be initialized to false, and we will have an array which will represent the path so far, and it will be a string, and it will initially contain the root.val, and we are also going to want a resulting number containing the value of the summation we want to return. So now all we have to do is just run depth first search, right? So while the length of our stack is not equal to 0, what do we want to do? We want to grab the node, we want to grab the visited boolean, and we want to grab the path. We can do that with stack.pop. Okay, now we need to grab the left and right subpaths because we will be building them on each iteration. So the left path is going to be equal to our path, and it will be a copy. The right path will be the exact same. Okay, now we need to check if our node is null or not. So we'll say if node is not none, we want to do something. What do we want to do? We want to check if we have visited this node before. If we have, we want to do something. So we'll say if visited is true, what do we want to do? We want to turn our string path into a number. So we'll say, actually, we also want to check if we have to check if we're at a leaf node, right? So how do we do that? We say if node.left is none and node.right is also none, right? Meaning we found a leaf node, then we can turn our path into a number. And we're going to do that by just saying value is going to be equal, we should actually write this out, value is going to be equal to an integer of the string join of our path variable. Right, so if we have 1, 2, and 3, that this line here is going to turn it into the number 123. Okay. Now what do we want to do? We want to add this value onto our resulting output. So we can say res plus equals the value. Okay, now we need to check the cases where we have not visited this node before. So we can say, what do we want to do? We just want to append the values onto our stack. So we want to say if node.right is not none, then we want to say stack.append the node.right child. We want to append the boolean of false, and we want to append the right path. The right path. But what do we have to do to this path before we put it on here? We have to update it with the node.right value. So we have to say right path.append the node.right.val. And we can do the exact same thing for the left child. So if node.left is not none, we want to update our left path to include the left node's value. So node.left.val. And then we can append this information onto our stack. The node.left child, the visited value of false, and the left path. Okay, now we also need to make sure we append our visited node to our stack, so we can always hit this case when we run into it. So we will say stack.append our current working node and the visited value of true along with the current path. And then after we exit all of this, we can just return our result. So let's get rid of some spaces and run this. Expected a string instance. Okay, what did I do wrong? Aha, right here. I appended an integer value instead of a string because that is what we were working with when we made our stack up here, right? Our path variable contains string values. So let's update this. We want to append string values. And the other one should be right here. Okay, now let's run this. Perfect, we passed both test cases, so we'll submit. And it does run, awesome. So time and space complexity. Time complexity is going to be O of n. We have to traverse all of the nodes in our tree, and the space complexity is going to be bound to the length of our stack. So we can say stack.length. All right, that'll do it for LeetCode 129.